Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray, and in this video we'll be looking at the compound angle formulas in trigonometry. That is the trigonometric ratios of the sum or the difference of two angles. So let's get started. Alright, so we'll start with the derivation of sine A plus B and then use this formula for the derivation of the other trigonometric ratios. So first, sine A plus B. Let's write the formula of this first. This is equal to sine A cos B plus cos A sine B. Now you should be careful that this sine A plus B is not equal to sine A plus sine B, which is evident from the formula above. So this is totally wrong. So let's derive sine A plus B, that is equal to sine A cos B plus cos A sine B. For that, I'll be taking a coordinate plane. On a coordinate plane, make an angle A like this and an angle B after A like this, and make two rays on these angles. Now from this point, make a perpendicular onto the x-axis. Also make a perpendicular from this point onto this ray like this. This is a perpendicular, and from this point where the perpendicular is the foot of the perpendicular, make a perpendicular again on the x-axis like this. Name these points. Say this is O, A, B, C, D. Now one more, from this point make a perpendicular onto AB like this. So this is 90. Name this point, say this is E. Alright, now let's look at what sine A plus B will be first. Sine A plus B. Now A plus B is this complete angle. So in this triangle AOB, sine A plus B is equal to opposite upon hypotenuse. So this is AB upon AO. Now AB can be written as AE plus EB. Alright, now let's separate them. Let's separate the denominator, and while doing that we see that AB is equal to DC, because this is 90, this is 90, this is 90, this will also be 90. This is a rectangle, so opposite sides will be equal. So instead of writing EB, I am writing DC. Alright, now after this point, an important manipulation. AE upon, in this first term we will multiply by AD. We will multiply the numerator and the denominator by AD. So denominator I am writing here as AD into AD upon AO like this. In the second term, DC upon, we will multiply by DO in the numerator and the denominator. So we can write this as this, DC upon DO into DO upon AO. What this does is AE upon AD. Let's look at this. AE upon AD. So in this triangle, AE upon AD. First, let's look at the angles in this triangle. Now this is angle A, this is 90. So this angle will be 90 minus A. Vertically opposite angle is this, so this is also 90 minus A. Now this angle is 90, D. This is 90 minus A, this is 90. So this angle here will be A. Alright, now if this is A, then AE upon AD. AE upon AD in this triangle becomes adjacent upon hypotenuse for angle A, that is cos A. AD upon AO. AD upon AO in the triangle AOD will be opposite upon hypotenuse for angle B. So this is sine B, plus DC upon DO. DC upon DO in the triangle DOC will be opposite upon hypotenuse for angle A. So this is sine A, and DO upon AO. DO upon AO in the triangle DAO will be cos B. This is written as sine A cos B plus cos A sine B, which gives us the compound angle formula for sine A plus B. Alright, so we got the formula for sine A plus B. Now we notice that we haven't specified the angles A and B, and there is no restriction here. So A and B can be any angle, and this equation is valid for all values of A and B. That means it becomes an identity. Alright, it is an identity which is valid for any angle A and B. So to find the angle formula for sine A minus B, for sine A minus B, what we do is, in this formula we will replace B by minus B. Since it is an identity, we can replace B by minus B. That would mean that sine of A plus minus B is equal to sine A into sine of minus B, sine A into cos of minus B plus cos A into sine of minus B, which is, now cos of a negative angle is same as cos of the angle, so sine A into cos B. Sine minus B will be equal to minus sine B, so we put the minus sign here and we get minus cos A into sine B. So this gives us the formula for sine A minus B. Let's write it here. This is sine A cos B minus cos A sine B. Yes? Okay. Let's look at cos A plus B. Cos of A plus B. Now, cos A plus B. Suppose this angle is one single angle, say we can take it as alpha or whatever you want to take it as. This can be written as sine of 90 minus A plus B. This is same as sine 90 minus alpha, which is sine cos alpha, so sine A plus B, correct? Write this as sine 90 minus A minus B, and we group 90 minus A. Now apply the formula of sine A minus B here. So we will get sine 90 minus A into cos B minus cos 90 minus A into sine B, which is equal to sine 90 minus A is equal to cos A into cos B. Cos 90 minus A is sine A, so minus of sine A into sine B. This gives us the formula for cos A plus B. Let's find the formula for cos A minus B. A minus B. Now for this, what we do is, again this is an identity, so we replace B by minus B in this formula to get cos of A minus B, which is equal to cos A cos of minus B minus sine A into sine of minus B. Cos of minus B is same as cos B, so this is cos A cos B. Sine of minus B is same as minus sine B, so this is minus minus plus sine A sine B. As this is minus sine B, minus into minus gets us positive in plus sine A sine B. So the formula of cos A minus B is cos A cos B plus sine A sine B. Now in the formula of cos compound angle, you should notice that cos of A plus B, so if there is a sum of two angles, in the middle here we get a minus sign, and if there is a difference of two angles we get an addition sign here. So be careful about that and just remember it that way, that a positive sign here means a negative sign here, a negative sign here means a positive sign here.